G'day everyone, back here again. I did this video before and my camera ran out of battery, so I've got to do it again. That's okay. I'll hopefully do it better this time. You're getting the take two version. Vector equation of a line. So what are we talking about here? Well, we know that in vectors and points can describe where things are at a particular time, but they also move. Okay, whether we're talking about ships floating in the ocean or we're talking about aircraft in 3 dimensions, we've got a starting point and we've got where things are going to move. So, vector equation of a line. Let's assume that we're going to start here at 2, 3. Okay, 2i and 3j, remembering that we've got our I here and our j here, and our k would be coming out of the board if we were in 3D. And we're going to move in this direction. Now, here's the thing with this move idea. That and something like 4, 2, they're in the same direction. But this one is going to be moving a lot faster than this one. Because this is, if you like, the velocity, the distance moved per unit time. Okay? Lambda can be lots of things, right? But usually it's based around time. So the values in here, it might give the same direction, but the speed is controlled by those values there. Okay? Let's not get confused here for a minute. So if we've got that, then this is my vector equation of a line. It's a point that I start at, plus so many lots of the distance and the direction that I'm going to move. So this is the distance and direction that I'm moving. So I've just got to put them together, and you can see that's what I've done here. Now, there's another way to write this if you want to. This is fine, but there's a lot of writing with i's and j's and stuff like that. So what you can do is write it like this. 2, 3, because the top number is the I, the bottom number is the j, and if you had a third number, that's the k part. So we kind of infer from that vertical notion what's going on, plus lambda lots of 2, 1. So that's a bit neater way of writing it. And when we do the next video that I've already done before this, this format is handy when you're trying to do things intercept, because you can just read off the top line and you don't have to kind of jumble around in the i's and j's trying to find the numbers that you want. Now, there's something very important here that I want to contrast to. Now, you would have done equations of a straight line on the Cartesian plane way back in year 9, perhaps even year 8. Well, this is really just a linear equation, because right here you have a start point. Now, with vector equations, that start point can be anywhere across the plane. On a Cartesian, on a linear equation for a Cartesian plane, what we would actually do is we would give that point the y-intercept, okay? Now, in theory, you could write a vector equation, a linear equation like this, and give this as an xy coordinate. It would still work, but we generally give it the y-intercept because that's usually a handy piece of information for us. But this is like the y-intercept, and then this part here, that's really like the gradient, because like I've got here, rise over run, it's telling you what's happening. Now, it's different because it's in terms of I and j, but this one is really like a gradient of a half, because rise over run. Well, that's really the i's over the j's over the i's. That will give you that value. We don't generally use gradient. We put it in this format because it's handy to know what it's doing horizontally and vertically. But this is essentially like the gradient. Oh, no, sorry. Jump back a little bit there. Let me put it around the right one. This one is really like the gradient. Whoops, my bad. Now, this one that I circled initially, that one is really like my x-coordinate on a linear Cartesian graph. But here, this is usually related to time, because these are based in kind of more reality. We're here at the moment, and we're heading that direction. Well, after 5 seconds, after 10 seconds, where am I going to be? So this is usually it's kind of like our x value, This is kind of like our gradient value, and this is really like our c value if we were doing y equals mx plus c. So they correlate pretty closely, but we've got to be careful the language is different and the meaning's a bit different. But see them just as linear equations in terms of vector. Hence it's a vector equation of a line rather than a linear equation of a line or a Cartesian equation of a line. Hope this one's helped. It's fairly straightforward. Once you've got it, I think you'll be right with it. Enjoy, guys. See you later.